and welcome to Data Solutions Heaven. My name is Fola, and I'm so excited to have you here with me today. If you're passionate about data, you're in the right place. So, if you are excited to learn, share, and grow, make sure you hit that subscribe button if you haven't already done so, and turn on your notification bell so you never miss an update or a new video when I upload one. All right. Let's get started into today's video. So today we'll be discussing data modeling in Power BI. Data modeling in Power BI. What is data modeling, you might ask? In simple terms, data modeling is the process of structuring and preparing your data for analysis and reporting to make it meaningful and actionable. It's more like getting all your ingredients ready to prepare a delicious meal. We can also say data modeling is a virtual representation of the associations and rules between your data tables, right? Now, you might ask, why do we need to model our data? Why is data modeling important? Because raw data can be messy, inconsistent, and difficult to work with. It's more like having pieces of puzzles to be put together to form and a clear and complete picture, right? Data modeling will also ensure data consistency, accuracy, and reliability. Also, we ensure we have our data in a standardized format. It can be likened to you building an architectural design for your dream home. So we can liken data modeling, right, to an architectural design for your dream home. Okay. What are the key reasons why we need to embrace data modeling? First of all, it improves the speed of data loads, especially when we have to load data from multiple sources. It also eliminates duplicates and erroneous entries. It provides users with a structured and easy to understand data set because your data set is now cleaned and in a structured, organized format. It empowers users to extract insight without struggling with data complexities. It also simplifies the process of answering complex business questions. Again, because your data is now organized and in a structured format, it's easy for you to pick out those data items or data fields that will help you to easily answer those business questions, which are the objectives of your data analysis, right? Okay, let's move on. So, what are the major elements of data modeling? In the world of data modeling, we often encounter two critical data tables or table types, which are the facts table and the dimensions table. Let's explore each of them. The facts table contains qualitative and measurable data, which are numeric values that we can perform calculations on. For example, sales revenue, profit, quantity sold, number of deals closed, etc. Fact tables are most often the center of a data model. They provide the metrics for the analysis. This is where we get insights into the major KPIs like total orders made, total revenue, total profit, total deals closed, things like that. These informations are usually contained in the facts table. Now, dimensions table. These are the tables that contain a descriptive attribute which provide context to the data in the facts table. They help us answer the questions such as what, when, where, and who, meaning they basically help us filter the data in our facts table. For example, things like date, product name, customer's name, region, and things like that are the kind of data items that we'll find in our dimensions table. So again, the fact table contains the numeric data, while the dimensions table contains the descriptive attributes, which we can use to describe the data in our fact table, right? Now, separating data into fact and dimensions table enhances clarity and performance, meaning that you know what table to pick what item from when needed. It also enhances performance because only the data items that you need will be loaded at every point in time. It simplifies complex data structures and enables efficient query execution. Relationships. Relationship is a concept that defines how our facts table and our dimensions table interact. For example, sales revenue from our facts table is analyzed by product name from our dimensions table. Another example, student score is analyzed, right, by student name in our student table. So student score will be our fact in our fact table, let's say student score table, and then we have another table called student details. So the student table, which is the fact table, will be analyzed by the student name, which is in the dimensions table. Let's move on. We cannot talk about relationships and not mention cardinality, right? So the concept of cardinality is basically that it determines how many rows in one table are related to rows in another table. We have four primary types of cardinality, which are the one-to-one cardinality, one-to-many, many-to-one, and many-to-many. So in the one-to-one cardinality, that's a type of relationship whereby each row in one table corresponds to exactly one row in another table. In the one-to-many cardinality, one row in a table corresponds to many rows in the second table. For example, as we can see on this screen now, one person has one heart. That's a one-to-one cardinality. The one team hires M employees. That's a one-to-many cardinality because one team can have as many employees, as many players as they want, right? Also, we have one to many, which is the opposite of we have many to one, which is the opposite of the one to many, meaning many players can belong to one team. Or we have multiple products belonging to the same category, right? Or we have many children belonging to one parent, right? Now, for the many to many cardinality, many rows in one table will correspond to many rows in the second table. So in this example, we have m number of classes enrolls n number of students, meaning that, or let's say m number of students can enroll for n number of courses. Many students can enroll for many courses, right? So that's an example of the many to many cardinality. Let's move on. Now, before diving deeper into data modeling, it's important that we familiarize ourselves with some fundamental concepts such as the primary key and the foreign keys. So, what is the primary key? A primary key is a unique identifier within a table. It ensures that each row in the table has a distinct and unique value. Primary keys are essential for maintaining data integrity, and they are usually not null values. Like I said, they are unique to every row of the data. For example, in an employee data set, we can have the employee ID as the primary key. That's the unique identifier that identifies every employee. We can also have matric number, for example, which will be the or matric number or student ID, which will be a unique identifier for every student. We can also have course ID, which will be an identifier for every course. Product ID, which will be an identifier for every product that an e-commerce store sells. Now, foreign key. A foreign key is a reference to the primary key of another table, right? Foreign key links data from one table to another table. Let's take a look at this example. So in we have two tables here, customers table and orders table. In the customers table, we have customer number, which will be the unique identifier for each of the customers. So for the first customer here, Sally Thompson, she has a customer ID of 1. Harry Henderson has a customer ID of 3. So those numbers, 1 and 3, are primary keys in the customer table because they uniquely identify each of these customers here. Now, moving on to the second table, the orders table here, we have order number, employee ID, employee number, customer number, supplier, and price. Now, the customer number in the orders table is a foreign key because it's only used here to reference each employee in the each customer in the customer table, right? So the primary key in the orders table will then be the order number because this is the orders table. So the primary key is the orders number, but the foreign key is the customer number, which is the primary key in the customer table. I hope you understand the scenario. Okay, let's move on. Now, star schema. Data modeling in Power BI often revolves around two main approaches, the star schema and the snowflake schema. What is a schema? A, a schema is basically a drawing that represents an idea. Basically a drawing, a relationship diagram a diagram that represents an idea. Now, the star schema is known for its simplicity and performance. Hence, it's the most widely adopted of the two in most Power BI projects. In the star schema, you usually will have one central fact table connected to multiple dimensions tables, just like we are seeing here. So the big one at the center will be our fact table, and smaller ones here will be the dimensions table, forming the shape of a star. That's why it's called a star schema. Okay. Now, for the snowflake schema, it takes a more normalized approach, meaning that it further breaks down each of the dimensions table into smaller subtables for granularity and precision, which can then lead to a more complex relationship between the tables and queries. So we can see here we have the facts table in the middle, we have the dimensions table outside, and then the dimensions tables are further divided into subtables, meaning making the relationship more complex, right? Because it's more complex than we have it on the in the star schema. So you may ask, which one is best? Which one do I adopt? The choice of whether to choose between the star or the snowflake schema will most times depend on your specific data and reporting needs. So if there's a need to, if your specific requirement entails that you go for the normalized approach, more granularity type of approach, then you can go for the schema. But for simplicity and performance sake, you know, the like I mentioned before, the star schema is the most adopted one. Now, let's dive into the practical session where we're going to put all the theory that we have learned here into practice. In the demonstration, we'll walk through the step-by-step process of creating a basic data model in Power BI. I'll see you in the practical section. So the first thing you want to do on any Power BI project or any data analysis project is actually to get your data, right? So I've opened a new Power BI desktop, and then the first thing is to get in our data. So you go to get data, and then you choose the source from which you want to get your data from. For this purpose, I have my data in Excel. So I click on Excel. I'll go to locate my data. I have it in, so I have my data in this folder, and then I have three files. So I'll be picking them one after the other. The first one I'll be picking is my fact table. Okay. So once you load in your data, it comes up with two options, either load or transform data. If you're sure that your data doesn't have any need for any data cleanup, if there are no null values, if there are no messy data that you need to clean up, you can just click on load and load directly onto your Power BI. But if you, it's always a good recommendation, right, to click on transform data so that you can just view the data again to ensure that there's consistency and integrity with your data. You do not have no values or anything of such. Okay. So once you load or once you transform, it opens up in Power Query where you do all your data cleanup activities. Okay. So for this is my fact table and that's my transaction table. Okay. So because it has details of sales transactions basically. Okay, the name of the product, the quantity sold, the unit price, the order date, the due date, the shipment date, and all of the information about the sales basically. So I go ahead and bring in my order data. So again, you click here, click on new source, and then click on Excel again because I have it in Excel. Okay, so I'll bring in my customer file now, and then click on OK. So I have it here. And then I click on new source again, go into Excel again and bring in my last table, which is my product table, and click on OK. Okay, again. Okay, so I have all my data imported in here. For my facts table, so what you will do once you have your data is to ensure that you have your dimensions table and your facts table. You remember we said the facts table contains numeric values, which are most times what we want to analyze, what we can data that we can aggregate on, right? So for this now, my fact table is fine because it has numeric values, details of my sales transactions. So if you scroll through and then my date, which is the order date and due date. So for my fact table, that is fine. And then if you look at my customers table, I have the details of my customers. That's the business name, the customer name, number of employees that the business has, the annual revenue, year the business was opened, and things like that, the address, the state. And then for my product, so my customer, before I move on to products, my customer table is a dimensions table. Remember what we said about dimensions table? They do not contain numeric values, they contain categorical or dimensional values, which are those fields that we want to use to filter on our fact records or our facts data basically. So they help us to filter our facts table. So for my customer table, I'm satisfied with what I have in there. Now for the product table, I have this information here. So you will see that I have the product name, the size, the more information about the product. Then I have the product subcategory and also the product category, right? But one thing to note is that we can have multiple products belonging to a single category. Also, we can have multiple products belonging to a single subcategory. So in situations like this, it would be best to have our category name and our subcategory name as separate tables, and then we can reference them from this product name. This way will reduce, it will help us to improve the speed of our data load, as we will not be importing this subcategory name so many times, right? So to do that, you just come here, double right click on the product table, and then click on duplicate. Once you click on duplicate, the first thing you want to do is to rename your table. So for this, I'll rename it category because I want to separate my category column from this table. Okay. So what you would do is, we're not leaving all of these columns here. We'll remove the ones we do not need. So what you want to do is click on the category name and then right click on the category name, and then you select this option that says remove other columns. Okay. Once you do that, you right click on it again and says remove and remove duplicate. So we have just 5 categories that are all our products belong to. Okay. So what this will be our category dimensional table. So what we want to do is to give this category, each of this category, an ID. And to do that, the ID will be the unique identifier for each of them now, which is the primary key. Remember we talked about primary keys and foreign keys. So to be able to assign a unique number or unique ID to each of them, we'll come here and say, click on add column, and then you click on index column. You can either choose from 0 if you want your ID to start from 0, or you choose from 1. You can also do custom column if you have a particular number in mind that you want to start from. For example, let's say I want to start with 11 and I want it to increment by 10. So the first one will be 11, the next one will be 21, 31, then in that order. So you click on OK. So I have 11, 21, 31, and then I rename my column category ID. So I usually like my primary keys to be the first column in my table. So I'll simply move this to the first column in my table. And now I have my category table set and ready for use. The next thing is to create a subcategory name. So the process we are doing here now, creating dimensional tables, removing, adding columns, is called normalization. So we're trying to normalize our data, right? Okay, so the next thing is to create a table for subcategory. You right click on the product table again because that's where we have our subcategory information. Okay, you click on duplicate, and then I rename my table to subcategory. And then again, we want to remove all the other columns that we do not need. So you right click on the subcategory name, and then you do remove other columns. You right click on it again and remove duplicate. So these are subcategories that we have. Again, we'll add one we'll add an extra column or one more column to this table so we can have a subcategory ID. And then this time around, I'll use the one that says from number one. And then I'll rename my column to subcategory ID. Click on enter, move this to the first column. Now, another thing, so we have all our facts tables and our dimensions table ready. So in this case now, we have one facts table, which is our transaction table, and then we have four dimensions table, which is the customers table, the products table, the subcategory, and then the category table. So it's always a good practice also to check through your data types to ensure that each of your columns or your fields have the correct data type. So for this is text, that's fine. For this is whole number, that's fine. If there's a need for you to change, you just simply click on that text data type and select the one you want from the field, right? Okay, so that is fine. Now, another important thing to do is to create a calendar table or a date table, because in our fact table, which is our transaction table, we have an order date, and we want to be able to analyze our data based on the order date. We want to be able to carry out some time related analysis, right? So it's always important to create a date table. Now to do that, you can go on to sorry. So to do that, you can go on to where's that again? I think it's on. Okay, so once this is done, I'll just close and apply first, right? I'll close and apply. Or before we close and apply, I'll come back to the date table in a moment. Just a moment. Before we close and apply, there's an important thing I would want us to do, because we will be creating relationships, right, between these two tables, all of our tables. We don't want Power BI to automatically detect the relationship for us. So you want to come here to the file menu, go to options and settings, then you click on options. Okay. Once you click on options, you come down to, you have global and then you have current file. Global, any changes you make on the global will affect each and every of your Power BI reports that you create from this moment. But any changes you make on the current file will only affect the current Power BI file that you're working on. It will not affect the subsequent ones. So for this, we'll click on data load under the current file, and then you uncheck under relationships, you uncheck auto detect new relationship after data is loaded, or import relationship from data sources on first load. You uncheck that and then you click on OK. Okay. So for this, another thing I would want us to do also is to link our category and our subcategory tables back to the product table, because we want to identify the category and the subcategory that each of those products belong to. So to do that, you click on the product table, you come to merge queries. So we have merge queries and we have append queries. What merge queries would do is to create a join between two tables, and by join I mean add the tables together, two tables together column wise, while the append queries will combine the table row wise. So column wise meaning it will add it to all the columns in table 1 and then selected columns in table 2 depending on the type of join you use. And then the append will add data row wise. For example, let's say I have 2017 sales data in a file, and then I have 2018 sales data in a separate file, and I want to combine those two into a single file. If they have the same number of columns, I will use append queries to join them. Okay. So for this purpose, we'll be using merge queries. So I click on merge queries, and then my first table is the product table, and then I want to merge a second table to it. So I simply come here and pick my category table first. Now, the next thing to do is to look for the field or the column that is common to both of them. So in this case, we have our category name and our product name common to both tables. So we'll create our join on that column. And here we can see the join kind, which is the left outside join, right? And what this means is that all the columns from our left table will be taken, and the matching column from the second table, which will be the second table in this case is our category table. Okay. And another thing you would want to watch out for is that both tables must have the same number of rows. So you can see this tick icon that says the selection matches 349 of 349 rows from the first table. So we're good to go. You click on OK. Now we have it imported here, but it's showing as table. It's not showing the name of our columns, right? So to expand, you click on this icon here. Click on expand. And now because we already have category name in our product table, we do not want to repeat it a second time. The only thing we need for to be brought forward into the product table is the category ID. So for that, we'll simply uncheck category name and then uncheck use original column as prefix, so we can retain our column name just as it is. Okay, once you do that, you click on OK, and then you can see that we have our category ID here. Now, because we have category ID here, we should not have category name again, because that will result into redundancy, as we already have a category table that has a category name. So for this, you right click here on the category name and say remove column, so that we have just the category ID, right? Now for the same, we'll take the same process to bring the subcategory ID into this table. So again, you go to merge query. Our first table is the product table. You select the second table, in this case is the subcategory, and then the common name to both of them is the subcategory name here and subcategory name here. Also, we want to use the left outer join. There are other types of joins, right? We have the left join. Like I said, to take all the columns from the left table and then matching records from the second table. Right outer join will take all the records from the second table and matching records from the first. Full outer join will combine all rows, all columns from both tables, right? So for this case, we are using the left outer join, and our left um our left table here is the product table, because that's what we want to join another column on from a second table. Okay, and then we also have the same number of rows, so that's fine. You go ahead and click on OK. You expand the table again. You deselect your subcategory name because we already have it here and we don't want to bring it in again. And then you click on OK. Okay, and then you go ahead and remove the subcategory name because we do not want it here to avoid redundancy. Okay, so you click on remove. Now, once you do that, you can decide to leave your category ID here and subcategory ID, but as a personal reference, I like to have them both at the beginning of my table. So to do that, you can click on both of them, click on one, and then hold your control key on your keyboard, click on the second to highlight both of them, and then you can right click on your mouse, right click on one of the columns, and then go to move to beginning. So to move to the beginning of the data for us, so we can have them here. Again, you may want to go through your data types to ensure that you have the correct data types for each of the columns. So I'll just go through mine quickly. This is whole number, this is text, this is text. Yeah. So all of these are fine. Now, once this is done, right, what you want to do is click on close and apply so we can if apply the changes onto Power BI. Okay. So it's importing the changes into Power BI here for us. Let's just hold on and wait for it to complete. Okay, great. So what we have our data now loaded into Power BI and we have all our tables here. So for, like I said, we only have one fact table, which is the transactions table, and the other ones are our dimensions table. If you want to have a glimpse of your data, this on the left hand side here we have three views: the report view, the date table view, and also the model view. So you come onto the date table view to have a look at what your data looks like. We already know what it looks like, but you may just want to do that. Now, the next thing for us to do is to have a date or calendar table created. Now, from here, from the table view, you click on new table here. Under table tools, you click on new table. Okay. And then we want to create a date table, so we can name that date equals to, I'll be using DAX function for this, and there's a function in DAX called calendar, which is what we'll be using today. If you want to take a look at the description, you can as well click on this arrow and it will tell you what the function is all about. It returns a table with one column of all date between a start date and an end date. So I've already made a video on how to create date table in Power BI. You may want to have a look at that. So for this purpose, I'll just be doing that quickly here. So I'm creating date and I'm using the date function. So the parameters it takes is the year, month, and day. Now, for this purpose, I'll be creating a dynamic date table because I want it to go from my minimum, from the list date I currently have in my fact table to the maximum date. So for this purpose, I'll be using the year because I want to get the year and the minimum date in my fact table. So that will be date column, other date column in my fact table. Okay, you click on that and then I'll close my minimum, I'll close my year, and then I want it to start from the first of January of that year and the first day of the month of that year. Okay, and then I'll click on comma to supply my end date. Again, I'll use the same technique. I want it to go through to the maximum year, so I'll be using um the year function. Sorry, I think I'll start with the date as well. I'll be using um the date function. Right, so you do date, and then the year will be my year, which will now be the maximum year in my fact table order date column. Okay, select that, click on this, close this, and then supply my month as December, which is 12, and my day, which will be the 31st, which is the very last day of the month of December. Okay, and then you close this, and then you close your calendar function, and then you hit on enter. Okay, so we have our date column calculated for us. The next thing to do is to click on that and format your date as preferred. I usually like to use the short date format, so I click on that. And from this column, I can go ahead and create my other columns, such as the quarter, the month, and the weekday, weekend, and things like that. So to do that, I click here on add column, right? And then I do quarter, quarter equals to use the format function, and then I use my date. So I want to format this date as quarter, right? And then I do this forward slash QQ so that to show as Q1, Q2, Q3, and the likes. Sorry, shift this, and then close, and then click enter. And then next thing you click on new column if you want to month number equals to month of this date, and then you close. Okay, and then I'll just do month name. I won't go ahead and finish the table. You can go ahead and do that. You can watch my video on how to create date table to complete that. So this one will be month name. I already have month number equals to, so I'll be formatting my date column, right? And as a short month, so I'll write MMM and then close on. Okay, so I'll be stopping here. You can go ahead and create the other ones, such as the day, the weekday, weekend, and all of that. Okay, so for this, I'll go back to, so I have my date table here, right? Now we are good to go. The next thing for us to do now is to create relationship between all of our tables, okay? Because we need to have a way to make them communicate, to interact with each other. And to do that, you click here on your model view, and that will show you a list of all the tables that you have. And this is the main part or the main essence of data modeling. And remember we talked about schemas, which is a structure, right, for how you create your data models. And I mentioned also during the theory part that the most commonly adopted form is the star schema. So that's what we'll be using here today. And when doing a star schema, you always have it is always recommended to have your fact table in the middle, because so that, and then your dimensions table to surround it so that it forms the shape of a star schema. And that's how it came about its name. So you have this here, and then I have one more table, which is the subcategory. The date table doesn't, yeah, so we can have the date table here as well. Let me just move things around a little, reduce my screen. So I think I've zoomed in too much. Okay, so we have our facts table here and our dimensions table all around. So the next thing for us to do is to create a relationship between each of these tables, right? Because we need to, like I said, have a way to make them communicate and interact. So to create relationships, we simply drag and drop columns from one table to the other, the similar columns that they have in common. So for customer table, what column can we say that it has in common with the fact table, which is our transactions table? So if you look through and scroll through, we will see that we have the let me have a look. Okay, the customer key. Yeah, this we have a customer key column here, and we also have a customer key in our customer table. So what you would simply do is click and drag the customer key from the customer table and drop onto the customer key on the transaction table. And that will create a one-to-many relationship for us. Remember, we talked about relationships during the theory part, where we talked about one-to-many, one-to-one, many-to-many, and the likes. So for this one, we have a one-to-many relationship because one customer can order product multiple times or many times, or one customer ordering many products, right? Now, we also have the date table that we can link onto the transactions table. And we are linking to the order date because we want to be able to analyze based on the order date, right? Okay. So we will simply click and drag the date column from the date table and drop onto the order date column on the facts table. Moving on, our product table, how does it relate or how does it link up with the fact table? We have this common key between them, the product key. So again, we'll simply click and drag onto this one. Okay. Now we have most of them are one to many. So we have a single date in our date table. We can have many orders from our transactions table on a single date. That's what this means basically. And then for the product, we can have one product from our products table that has been ordered or is being ordered multiple times. So that's why we have a one-to-many also on this one. Now, for the category and the subcategory, they do not directly link up to the fact table, but rather will link them up to the product table, which then in turns link to the fact table. Okay, so to link up the category ID in a similar way, you click and drag your category ID and drop onto the category ID here. And then for the subcategory, you click and drag again and drop onto the subcategory table. So that's simply all it is about creating data models. So like I said, the first thing you do is to get in your data, clean up if there's a need to clean up your data, normalize your data by creating new columns, removing columns that are non needed, creating additional tables such as your dimensions table and your date table, and then you go ahead and create your relationships, and that is it for data modeling. So you can go onto your report view and create your visualizations as you would normally do. So that is it all for today's video. I hope you've been able to find it helpful. If you haven't subscribed yet, kindly do well to subscribe, drop a comment, like, and share. Thank you for watching, and I'll see you in my next video.